next and previous, and here you know what is the meaning of it. Here the next is the first element, okay, and here the previous is basically the last element. So this is the circular doubly linked list, and this is head or start, whatever you want to say. And now the first thing, suppose that we want to insert at the beginning. So first condition is that the linked list is empty, as you have seen in the others also. If linked list is the empty, then we want to insert one node. Then first we need to check whether the linked list is empty or not. If it is empty, and so this is the new node at the starting, as we have prepared in all others cases, we will prepare a node. Okay, so this is an obvious condition. Where first we create a node like the new node, you can say new node is there, new node, and you will apply a malloc function over here. If this new node is equal to null means if there is no sufficient space in the memory, then definitely you can means print here the overflow, and then you can exit, means you are not in the position to create the new node. So this is, we are assuming that we have created the new node. Okay, if it is not there, then we are printing the means the overflow condition. And if we have created the new node, then we will put the data into this. So we are considering that we have created the new node and it is ready with the data. New node, okay, new node, and it is ready with the data. Okay, new node, or the data field is containing the data. So how we will check? First we will check whether this linked list is empty or not. If it is empty, then what we will do? If head is equal to means head is equal to null. Empty means it is null, head is null. Then in that particular case, what we will do? The one node is there, then the linked list will be like this. This one, this is the head, and the single node is there. So the next of it is printing to this node itself, and similarly the previous one is pointing to this node itself. So if only means initially if it is empty, then what we will do? We will do that. The new node of next is equal to new node, and new node previous is equal to new node, and head is equal to new node. Then this is the thing that we are going to do. Otherwise, if it is not the case, then in that case, what we are going to do? This is the thing that you can understand. Suppose that this is the new node, okay, and what you need to do here in that particular case, what you need to change? First, you need to think about that. What you are going to change? So what you are going to change, basically this pointer, and this pointer at the last you are seeing this pointer. Basically, it is going to point to this, and here, okay, and here also in the next of it, you are going to means you are going to like something like this. This is going to this pointer is going to be like this, okay, and this one is going to like this, okay, and this is going to print this next node, and here this is going to point to this one. So this we want to do. So how we can do? This node is required. We require this last node also. So by using this head, we can have the last node. How we can have the last node? Suppose that like this. Last is equal to, क्या हो जाएगा अगर हम देखें last is equal to? Tell me, anyone? Can we have this last node by using the head? Last is equal to, what is there?
Head previous.
Head previous. So this is simple, head previous. So what we can do? Head previous. So last node means this is pointing to the last node. Then now the operation is very simple. So what we can do now here, because what we are doing here, this next new of next is equal to, we can do the head. New of next is equal to head. Okay. New of next is equal to head, that we can do. Okay, or what we can do, and this head previous is equal to new node, and then we are having the last also. Last also we are having. Then what we will do? Last of next is equal to new node, and new node previous is equal to last. So that we need to do. Okay. So here even you can see the in the algorithm we have done the same thing. So this you can see void insert struct node. This is the new node. Suppose that we have created the new node. However, you can write the condition over here. If new node is equal to null, then there is overflow. And then we have put the value into the new node. Sorry. Then if head is equal to null, it means if the linked list is empty, in that case what we are going to do, new node of next is equal to new node of previous, because the node itself, it is pointing, both the pointers is pointing to the node itself. Okay, so new node of next is equal to new node of previous is equal to new node, that we are going to do, and head is equal to new node, and then return. If the linked list is empty, then we are going to insert the first node, very first node. Otherwise, if this is not the case, then we have created one more pointer that is pointing to the last node. Okay, that is pointing to the last node because it is required to us. So in case of doubly linked list, one advantage is this. In case of circular doubly linked list, one advantage is this: we don't require to search the last node, because last node is easily accessible. It is easily accessible. With the help of this last pointer, we can, what we can do, head previous, it is storing the address of the last node, so we can have the address of the last node in the last pointer. Then simply what we have done, new node of next is equal to head. Obviously a new node is equal to head, then new node previous is equal to last, and a new node next is equal to head, and new node previous is equal to last, obviously, and then update the next and previous pointer of start. Then last of next is equal to what it will be, last of next, last of next होगा क्या, new node. तो last of next same, head of previous, last of next and head of previous is equal to the new node. Head of previous means head previously pointing to the previous node. Okay, so head of previous is equal to new node, and now we have changed the head is equal to new node. Okay, so if we are doing the head of previous, then this line we cannot do in between. Okay, last of next is equal to head of previous is equal to new node, and head is equal to new node. So this is so easy, we can do that. Okay, is there any doubt in this?
No, sir.
Sure. No, sir. Insertion at the end of the list. So this is also same. First, what we need to do, first we need to check whether the linked list is empty or not. If it is empty, then the same case is applied over here. Okay, then if it is not empty, then we will set a position. What we required, that you need to see in that case. Okay, what you required in that case. If you are going to insert in the last, okay, so the same thing is here. Here we have created the node. Here you can see struct node, new node is equal to malloc size. Okay, if it is, you can even apply the condition if new node is equal to null, means the overflow is there. Otherwise, the else part you can do. Then new node, you have put it the value into the node, you have set the value. Then if head is equal to null, it means it is empty. In that case, what we are going to do, new node of next is equal to new node. The same case is there. If it is means only if the linked list is empty initially, then whether we are means inserting the node at the beginning or the last, both are the same thing. So new node of next is equal to new node of previous is equal to new node, and head is equal to new node, and then return. Okay, otherwise what we are going to do, the same thing, the last we will have last is equal to head of previous. Okay, this is the case. 1 minute, just take one pointer pen. So this is the you can say the node, last node is that. Okay, and after that we want to insert. Okay, after that we want to insert. This is the, suppose that this is the starting one, just consider only like this. So this is the node that we want to insert. Okay, so this is last, sorry, this one is the last, this one is the last, this one. Okay, so what we have done here, this is the new node. So new node of next, obviously this is head, new node of next is equal to head, and then head of previous. Head of previous means this one, the starting point. It is now, it is linked over here, okay, is equal to new node. And then new node of previous, new node of previous is equal to last, obviously, and last of next is equal to new node. Okay, this is so simple. Okay, so last of next is equal to new node. So it easily we can apply this particular operation. So is this clear how we can insert at the end?
Yes, sir.
Now in the middle, how we can insert in between? Suppose that we have this is the situation. We want to insert after a particular node, like this is the situation. Okay, so here function to insert node with value as value 1. So value 1, suppose that the value which we want to insert, and suppose that the value 2 is the value and after which we want to insert. The node is inserted after the node with value 2. So what is the case? There is a linked list, circular linked list is there, and nodes are having certain key values. Then one key value is there that is matching with this value 2. After that we want to insert the node. Okay, so the same thing is here. First we will create the node. First what we will do, we will create the node and we will set the value. Here you can see. Then one temporary pointer we will create and we will assign to head, and we search the node, है ना? तो while temp of data is not is equal to value 2.
सर आपकी आवाज कट रही है बीच में थोड़ी.
Yes.
सर आपकी आवाज कट रही थी बीच में.
आवाज कट रही है, एक मिनट रुको जरा, सिग्नल प्रॉब्लम हो सकती है. Just wait for a minute please.
सर अब सही आ रही है.
कोई बात नहीं, सिग्नल स्ट्रेंथ कई बार काम हो जाती है यहाँ पे, शायद इस वजह से. रुको. हाँ. So what we are doing, we are searching the node, है ना? And we are finding out the node. So the node that we are finding out, suppose that this one is the node, है ना? You can see. So what we are doing here, while temp of data is not is equal to value, we have applied a loop. If temp of next is equal to head, and suppose that we are searching and we come back to the head, it means we are not matching any node in between. Okay, it means the value is not present in the list, then return. Otherwise what we are doing, temp is equal to temp of next. Every time we are increasing to the temp. So because we are checking the temp of data is equal to value, so temp is basically pointing to that particular node. Temp is pointing to that node after which we want to insert the value. So what we are doing over here, we have created another node that is called PTR is equal to temp of next. So one node is there, one more pointer is there. Okay, this is temp, and suppose that the next one is the PTR. PTR is there. Okay. Next, this one is PTR. This one is PTR, and this one is temp. Okay. This is temp. This is PTR. So how we can insert? This is the new node. Suppose that this is the new node. So new node, easily what we need to do. This is the temp. To temp of next is equal to new. Okay, temp of next is equal to new, and new of next is equal to like PTR. Okay, similarly the PTR of previous is equal to new, and new of previous is equal to temp. And after that, okay, we can easily insert that particular. So here you can see struct node PTR. This is the next, and then temp of next is equal to new node. Temp of next is equal to new node. New node previous is equal to temp, this pointer is there, and new node of next is equal to PTR, and PTR previous is equal to new node. So it is very simple, we can insert like that. Okay, I think it is clear to you. It is very simple, even simpler than the singly circular linked list. Now the deletion operation, and a deletion is also easy in case of the doubly circular linked list. So deletion in the same, like in case of deletion also, we can delete from the starting, from the last, or after a particular node, we can delete. So just see how we can delete. The deletion from the beginning of the doubly circular linked list. So first condition is that, like if head is equal to null. Null means the linked list doesn't containing any node. It means linked list is empty, or we can print the underflow condition. Otherwise, one more case is there sometime, because if the linked list is having only one node, then this case is different. Like this is the case. Only one node is there, like start, and only one node is there in case of doubly circular linked list, where it is pointing to itself, like this one, and this is the start. So in that case, also what we need to do, we need to delete this particular node basically, and we need to set start is equal to null. Okay, and we need to free. So what we need to do, suppose that one temp is there and temp is equal to head. Okay, temp is equal to head means we are saving this address of the node in the temp, and then after that what we are doing, we are free means we are deleting this particular node memory, we are going to free. Okay, so it means if only one node is there, what is the meaning? The head of next is equal to head of previous, obviously, because both the fields are means pointing to the same node. Okay, so if this is the case, or you can say the head of previous is equal to head of next is equal to head, this is also the same thing. If this is the case, then what we are doing here, head is equal to null and then free temp. Here we have assigned the temp is equal to head initially. If head is equal to null, it means the underflow condition is there. And then else if head of previous is equal to head of next, means the list is having only one node. So we are going to delete it, or we are going to set head as a null, and we are going to delete it. Else, in other case, if like this, suppose that this is the case.